Hello my dear students, how are you all? Welcome back to our YouTube channel Karnataka. I hope all of you are doing very good, bacha. Yes, so as per your requirement, I am back with your revision of midterm mathematics, right? For your PU2 portions. Today's chapter of discussion will be what, bacha? It will be relation and functions and inverse trigonometric function. Yes, so what we're going to do in this chapter today, in the session today, is we'll take up questions. So for example, we'll take up 15 questions in the first chapter and we'll revise our concept through these questions. So what I'm trying to say is, if you solve a question which is not been done in the session, you should be able to solve that question from the concept that you have revised in the session today. Okay, wherever I feel that you need to have more revision from the concept side, I will take the things additionally, but the chapters where we don't need that much, I will revise through the questions only. I hope this is going to be very simple and helpful. Okay, chaliye. So as I said, first chapter coming up is relation and functions. So make sure this is again we have a crunch of time. So and you also have your midterms coming up. You will have other subjects also to prepare and revise. So do not waste your time. Whenever you are watching this video, make sure that you are watching it complete and complete that particular chapter revision at that time only. Do not leave it for, okay sir, I'll do it, maybe after half an hour, after 1 hour. If you are watching this video, complete the video and solve all the questions, okay, with learning all the concepts. If you have a doubt, if you, let's say, while solving a question you have a doubt, okay, do one thing, write question number 1 or question number 2, write your doubt, whatever you feel, write in your statement, in your word, sir, I did not understand this line. You write the word, okay, write your doubt there and the same thing you put in the comment. I will reply to that. I'll try to come up with all the answers, whatever you have your doubt, and I will try to complete your revision with no doubts. Okay, chaliye, then let's start with the first question. What is it, sir? First question coming up is on, again, relation and functions. Let's see. So that the relation R1 in the set of real numbers are, okay, chaliye, so they have given the name of the relation. Relation R1 hai bhai, chaliye, okay. Defined where? Where is the set defined for? Okay, defined for the real number R, okay. This is how that relation is defined. Means ordered pair is there A comma B such that A is less than B square, okay. Check whether it is reflexive, symmetric or transitive, okay. Means whether it is all three, whether it is only two, or whether it is none of it. So we have to check this situation for the given condition A is less than B square. This kind of question has been asked. I think you must have solved this question in the class also, in the regular classes. Yes, chaliye, let's see. So we'll try to understand this with the help of example. So let's take an example. So basically, I have to check for equivalence whether it is not, because if I check for equivalence, I'll get the idea whether it is reflexive, symmetric and transitive. So if I take a set AB, I have to take from where? Real numbers. It has to be real numbers, so I can take whether a fraction, negative number, positive number, all is allowed because it is a set of what, which please understand this. Sometime what happens now, you take real numbers but it is given as natural number, then your answer will be wrong. So I've taken a question like that where set is defined on real number and the next question the set is defined on natural number. So you see the difference in the answer, okay, chaliye. So here in this condition we have set of real numbers. So if I take the example as, let's say, 1 by 2, okay, 1 by 2 if I take, and I check for reflexive, I check for reflexive, A should be, so in this case what will happen in reflexive, if you remember, again this is small revision, this is the notation for reflexive. ARA means the number, the element from the set, which is where the relation is defined, should be related to itself. So means A is the element, it should be related with itself. So ARA, A related to A, right? This is clear. So 1 by 2 should be related with 1 by 2. 1 by 2 should be related with 1 by 2. Whether it is not, we'll check now. So we'll put in place of one of the number A. What is the condition? A less than equal to B square. So 1 by 2 is here, and what is this? 1 by 2 whole square. How much is that, bacha? Please check. Less than equal to 1 by 4. Is it true? Is it true? Is 1 by 2 less than equal to 1 by 4? Is greater than, right? So not possible. Not possible. It means this condition, if I take a number 1 by 2 like this is not valid. Means what happens? There exists a element 1 by 2 in the set where what? Of real numbers where this is not defined. Understand this very important. This is very important. What happens? No, you will come up with an answer, sir. What if I take 2? What if I take 2? 2 and 2 square. 2 is less than 2 square, no? So 2 less than 4 means yes, this is valid. We will not check whether it is valid. Even if at one point it is not valid, then this relation will not be reflexive. So do not check for the point where it is valid. Check for the point where it is not valid. Okay, that will reach the answer or conclusion fast. Chaliye. So 1 by 2 we have taken, it's a real number and not reflexive. Quickly, so not reflexive. Reflexive तो नहीं है. What about the next part बच्चा? Please check. Symmetric कर लेते हैं. जल्दी से symmetric कर लेते हैं. Symmetric में क्या हो जाएगा? Symmetric will be, again I'll take an example. I can take what? Let's take this number 2,7. Means why 2,7 sir? Ordered pair is there बच्चा. A, B is there, so ordered pair. So A is 2, B is 7. Okay. So what is symmetric relation says? The definition of symmetric relations: if A or B is true, if A or, this is my if condition, then what bachcha? B or A has to be true. Correct? So apply this here, 2 or 7. Okay? Then what happens? 7 or 2 has to be true. 2 or 7 means what? Please tell me. 2 or 7 means what? 2 is less than equal to 7 square, right? So 49. It's true, right? Correct, na? 2 or 7 means what? 2 is A and 7 is B. So 2 is less than 7 square. So 49. So this is correct. Okay, what about this condition? What is this condition? 7. 7 is less than 2 square. How much is that? 4. Is it true? Not true. Not true, right? 2 is less than 49, but 7 is not less than 4. It means 2 or 7 is still true. Please understand this. 2 or 7, this part is true. Wherever this part is not true. But symmetric relation says that if A or B is true, then B or A also has to be true. Okay? Then in this condition what we can say, symmetric भी नहीं हो पाएगा. Symmetric भी नहीं हो पाएगा. Okay? चलिए आगे बढ़ते हैं. Let's move on to the next problem, next part. What is it? Transitive कर लेते हैं. Transitive. Okay sir. Transitive कर लेते हैं. Transitive. Transitive के लिए let's take example. So I have to, let's find the definition first. What's the definition of transitive? If you remember, A or B is true. This is again if condition. So if A or B is there and B or C is there, where? In the relation. If A or B is there, if B or C is there, then what bachcha? A or C should be there. A or B there, B or C there, then A or C should be there where? In the relation. Okay. Chaliye, then let's take example. So let's take A equals to 3, B equals to minus 2, C equals to 1. Can we take this? 3, please check, 3 is less than 4, correct? This is less than 1 square, correct? Okay, chali, this is correct, this is a correct example. So if we take 3 minus 2, 1, can we take 3 minus 2, 1? Yes sir. Why sir? Why? Real number hai bhai. Real number they have given. 3 minus 2 and 1 are real numbers. Why I am checking only these numbers, sir? Why can't I take other number? I said to you, what you have to check? Check for the point where it is not valid. If you can't find a point where it is not valid, then it is, what do you call? It is reflexive, symmetric or transitive. Check for the point where it is not valid, not true. So please check for the AB. Check for the AB. What happened with AB? So A or B will become this 3R minus 2. है ना? How much is this? Please check here. 3 is less than equal to minus 2 square. So which is how much? 4. So this is correct. This is valid. Okay. What about next one? Minus 2R1. What it means? It means minus 2 is less than 1 square. Valid or not? Valid sir. Minus 2 is negative number. 1 square will be a number 1. Obviously negative number is less than any positive number. Next is going to be what? A, B, B, C. Next will be AC. So please check. 3R1. 3 is less than equal to 1 square. Is it possible? Not possible. Now check here. ARB exists, BRC exists, but ARC does not exist in the relation. It means transitive bhi nahi hai bhai. Okay, transitive bhi nahi hai. What is the answer? Not reflexive. Reflexive, no. Symmetric, no. And transitive, also no. So these are cancelled. Okay, no. None of these are valid. Reflexive भी नहीं है, symmetric भी नहीं है और transitive भी नहीं है. Okay, moving on. चलिए. Question number 2. Similar kind of question. Check whether the relation R in R. See, from the first question we learned the definition of all the relations: symmetric, transitive, and reflexive. Okay, ARA, ARB, BRC is there. If ARA is there, then BRA will be there for symmetric. If ARB, BRC is there, then ARC will be there for transitive. Okay. So that's what I'm saying. I'll revise the concepts from your what bacha? From your questions only. Check whether the relation R in R means defined where? Real in real, okay, in the relation R, defined as R equals to AB. Again, ordered pair is there, bacha. Ordered pair, okay. The element is ordered pair. A is less than B cube. The relation is A, not A cube, forgive me. A is less than B cube. देख लीजिए, look at this. A is less than B cube. Please look at here. A less than equal to B cube is my condition for the relation. Okay. Example देख लेते हैं. We'll see from the example only. We have to check for reflexive, symmetric और transitive. कर लेते हैं. Let's take 1 by 2 again. Simple 1 by 2 I can take. Real number it is. Why real numbers are check here? Real number only. Real number in the relation R. Okay. The all elements are of real numbers only. Okay. चलिए. So reflexive 1 by 2 means. Reflexive means what? Again ARA. So 1 by 2 R 1 by 2 is 1 by 2 less than 1 by 2 cube. 1 by 2 less than 1 by 8. Is it true? No, sir. 1 by 2 is more than 1 by 8, right? 1 by 2 is 0.5. 1 by 8 will be what? So 0.1 something, correct? 0.1 something. So it is less. It is less than. It is not less. It is greater than. So not reflexive. Reflexive not possible. Okay. What about next one? Let's check for what do you call symmetric? Let's check for symmetric. Take an example. I can take 1 and 2 only. 1 and 2 will work. Yes, sir. 1 and 2 will work. Please check. So what is the condition? Condition for symmetric will be, if you remember, ARB, BRA, both should be there at the same time. ARB means what? ARB means what? Look at here. ARB means 1R2. Okay, 1R2. What about this? It means 2R1. Correct. Now my A is 1, B is 2. So 1R2 is my ARB and BRA is 2R1. What is my 1R2? Please check here. Please check here. What is my 1R2? 1R2 means what? 1 less than 2 cube. Correct? Correct. 1 less than 2 cube means correct. No, 1 is less than 8. What about next one? 2R1. 2R1 means 2 less than what? 1 cube. Is it correct? Is 2 less than 1 cube? Not correct. No. 2 not less than 1. 2 is 2. I'm sorry. 2 is less than 1. Not possible, right? So again, this part exists. 1R2 exists, but 2R1 does not exist. So not symmetric. Not symmetric. ARB to hai, but PRA not there. Check for transitive, please. Check for transitive quickly. Let's take. I have to take 3 numbers. What is the condition? ARB, BRC, then ARC must be there. ARB, BRC, then ARC must be there in the relation R. Okay. चलिए. Take the number 100, 5 and 2. Can I take 105, 2? Please check if it's possible to check at this point. If you have other example, you can try there also. But I think 105, 2 should work. So my A value is this. This is my B value. This is my C value. First check for ARB. ARB if I take, it will be 100 R 5. Is it true? 100 is less than equal to 5 cube. 5 cube is how much? 125. Correct. Okay. Check for other one. 5R2. 5 is less than equal to what, bacha? 2 cube. Also correct. 5 is less than 8. Correct. Now 5R2. BRC I am writing. 5R2 is BRC. This part. Okay. So 5 less than 2 cube, which is 8. Correct. What about last one? ARC. So A is 100. C is 2. So 100 R2 means 100 is less than 2 cube. Not possible. 100 is not less than 8, right? So it is not transitive. What is my answer? Please understand this. Not transitive. So what is my answer final? Not transitive, not reflexive, not symmetric. Okay. Not reflexive, not symmetric and not transitive. I hope this is clear. Is this clear, sir? Very simple question. 2 questions, similar concept, but this is revised. I will have no problem in the understanding of the relation like this. Okay. चलिए आगे बढ़े. Okay. Again, different variety of questions I have taken. So that the relation R in set A. Okay. In set A. Now set A is defined like this. Please look at this. All what? Z means what? Integers from 0 to 12. Means let's write set A. all the elements 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 and 12 bacha. Correct. Now this is given, this is the definition of what do you call the set A. I wrote set A. Now the conditions, look at the conditions. They are saying the relation R, again ordered pair A comma B, where the modulus of the difference of the two elements is multiple of 4. Check it is equivalence or not. Check it is equivalence or not. The question has two subparts. First subpart we have to check for equivalence. Second subpart also we have to check for equivalence. Okay. Then the last part we'll see, find the set of all elements related to 1. Means we have to write this condition with respect to 1. Okay. Means I have to write the relation R with 1 in it, and the second one also write the relation R with 1 in it. Chalo, kar lete hain. Let's do it. First part we'll see. First part, do you have space? I have enough space. Chaliye. Okay. Excuse me. So that relation R in set A तो define कर लिए. A comma B, A minus B difference is multiple of 4. तो reflexive check करें. Let's check for reflexive. Reflexive. Oh, this is the reflexive, right? ARA, right? Reflexive is ARA. So whatever is the number A, it will become what? It will become A minus A the mod. Simply will be 0. And 0 is a multiple of, okay, I can write, no? I'll divide this 4 by 0, right? So it will be possible. So reflexive is there. Reflexive. Yes. Okay. 0. Okay. आगे बढ़े. Let's see. For symmetric. For symmetric. Symmetric means what? ARB, B, and then BRA. ARB means, so ARB means what? It means they're saying that A minus B, this is a multiple, very small, so write a little bigger. I'm writing for ARB. Symmetric we know, right? ARB is there and BRA also has to be there. So we are writing for ARB first. ARB means what? A minus B. ARB means what? A minus B mod. So is a multiple of 4. If this is there, obviously, then B minus A will be there, no? Is multiple. Think about it. If let's say 2 minus 6 is multiple of 4, right? 2 minus 6 is how much? 4. So 2 minus 6 mod will become what? Plus 4 only, correct, right? Then 6 minus 2 will become what? Again plus 4. So whether if the difference is a multiple of 4, doesn't matter you take from the negative side or positive side, because mod will be there. So B minus A will also be mod, what do you call, multiple. So what will happen? What is my answer for this? Symmetric, yes. Reflexive was also yes. Symmetric is also yes. What about transitive? Check here, transitive. Check for transitive, please. I can write it over here also. Let's use this space. Transitive. For transitive, what will happen for transitive, bacha? ARB. Okay. ARB. So basically what? A minus B is a multiple. Next what? I have to write BRC also. These are my if conditions, no? So B minus C is a multiple. What about the next one? Then ARC should also be there. Okay, let's check how. We'll take an example. Since they're asking with respect to what? For the set A, we'll take with the set A only. Okay, we'll take with the set A only. Okay, can I figure out any number? So 2, 6, 10. Can I take this? 2, 6, 10. Please check here. This number 2. I'm taking this number 6 and this number 10. 2, 6, 10. Okay. Why? You'll see. So if I'm writing 2R6, what will this be? 2 minus 6 mod. How much is that? Plus 4 is a multiple of 4. Correct. Next you take what is it? 6R10. So I'm taking 2, 6, 10, right? So 6, 10 will be what again? What? 6 minus 10 equals to 4 is a multiple of 4. Correct. Next will be what? 2R10. How much is this? 2 minus 10. How much is this? 8. Again a multiple of 10. It means if ARB is there, BRC is there, ARC will also be there. So again this condition is validated. Okay, but they are asking, so transitive is there, it's transitive, so it is equivalence relation, it is a equivalence relation. This is my answer, but this is not complete answer. See what they're asking. Write the set of elements related to 1. Means if I am taking, for this condition, if I am taking this element 1, what number should come next? So obviously I'll have 1 with 5, correct? 1 with 5 will be there. 5 minus 1 is a multiple of 4, and I have to take what? 9 also. 9 minus 5 is also a multiple. Okay, so 159 is a valid answer. Can I take 13? 9 plus 4 will be 13. 13 cannot come because number is defined from 0 to 12. So this will be answer. Now you might ask, why not 2, 4, 6? Why not 0, 0 then 3, like 0 then 4, like this? 2, 6, 10, why not 0, 4, 8? Why not all these numbers, sir? Because they are saying related with 1. Read the question. They are saying what, bacha? Related to 1. So that's why I have a restriction given with 1 in the element. Take a set where I can define what? This equivalence relation. So 1 minus 5, yes. 5 minus 9, yes. If 1 5 is there, then 5 1 can also come. 5 9 is there, then 9 5 can also come, right? So symmetric bhi ho jayega. 1 1 can also come, 5 5 can also come, 9 9 can also come. So I can write the relation. I can write the set X, let's say, like this, which will be equivalence relation for this given condition. So question is, write a set where this condition which is given, okay, difference, also difference of the mod, so the mod of the difference should be equivalence. This will be validated. So if I write this relation X on X, 1 comma 1 will come, again it's valid. 5 comma 5 will come, valid. 9 comma 9 is come, again gonna come, so will be reflexive. 1 5 is there, so 5 1 will also come. 5 9 is there, so 9 5 will also come. So again symmetric. What about this? 1 5 1 5 5 9, then 1 9 is also there. So okay, I can write this set X related to 1 as equivalence for the given condition, difference is modulus. I hope this is not too much. Okay, did I explain too much? Okay, if you have this problem, I can leave the question answering like this as 159. I don't have to explain that much. Okay, chaliye aage badhte hain. Second problem, A B such that A equal to B. This is so easy. So for reflexive, A equal to B means what? A equal to A. So true na? Any number will be equal to itself, right? Any number will be equal to itself. So reflexive, yes sir. Big yes to reflexive. What about symmetric? Of course sir. Think about it. If A is equal to B, then yes, B is equal to A, right? Then again yes sir. Symmetric means what? ARB, BRA. So yes, true. What about transitive, sir? What about transitive, sir? Tell me. Okay. Transitive will be what, bacha? Please check. Transitive will be if A equal to B and B equal to C, then of course A will be equal to C, right? So again, big yes. Big yes. Think about it. A equal to B, B equal to C. Then obviously A equal to C. Now if you write this set, write a set for the where the element 1 has to be there. So I can write only one such number. I can write only one such number. So this set will be what? This set X will be given by 1. Because 1 is the number which is equal to itself. So again symmetric, 1 equal to 1, then 1 equal to 1. Symmetric also true, reflex also true. 1 equal to 1, 1 equal to 1, then 1 equal to 1. Okay. So I have to write with only 1 because they are asked for related to 1 in each case. So for both the cases, I have the final answer as 159 and just 1. To my two final answers. Okay, this is for second condition, this is for first condition. Moving on. Okay, question number 4. So that the relation R in the set T of all triangles in a plane given by, okay, so this one represents triangle, T1 is a congruent T. Okay, they're talking about congruent triangles, man. Chalo, simplest question ever, sir. Simplest ever. Think about it. A triangle, if I'm writing just T1, it will be, sir, related with T1, no? T1 is congruent to T1, right? Give me 1 second. T1 will be congruent with T1. Same triangle will be congruent with itself. I can overlap, same triangle will be like this. So, reflexive, yes. Check symmetric. Please check symmetric. If T1 is congruent to T2, then obviously T2 will be congruent to T1, right? T1 congruent to T2. Then T2 congruent to T1. So, this is also symmetric. Okay, take the other one, transitive. Take transitive. Transitive means what will happen? T1 is congruent to T2. T2 is congruent to T3, then of course T1 will be congruent to T3. So yes, think about it. T1 overlaps with T2. There is another triangle T3 overlaps with T3. Sorry, I'll repeat. T1 overlaps with T2. Triangle T3 overlaps with T2. It means T1 overlaps with T2. So T3. So T1 overlaps with T2. T2 overlaps with T3. Then T1 overlaps with T3. So congruent, congruent. Then it will be also congruent. So it is a equivalence relation. Okay. Relation is what? Equivalence. Very simple question. Very, very, very simple question, sir. Chaliye. So that the relation R in set A of points in a plane given of this. This is my relation. P comma Q dotted pair. Distance of the point P from the origin. So there's a point like this. So point P over here, and somewhere there's a point Q over here. They're saying this distance OP and OQ is same. Check whether it is a equivalence relation or not. Okay, let's check quickly. First one, reflexive. First reflexive. What will happen? Obviously, ARA has to be true. Means OP will be equal to what? OP, no? So reflexive, yes. A length will be equal to itself. So OP will be equal to OP. What about symmetric? OP will be if OP is equal to OQ. Let's say I've taken 2 points. OP equal to OQ. This is my symmetric condition, no? Then obviously OQ will be equal to OP, right? Correct. Now how will I write this relation? OP, okay, sorry. Please check. PRQ, right? PRQ is what? This one. And what is this? QRP, right? This is PRQ and this is my QRP. Second line. The second line is QRP. So OP equals to OQ, then OQ equals to OP. One equal to, let's say I have A equal to B, then B equal to A. Same thing. Symmetric, yes. Check for equivalence. Check for transitive. If I have OP equals to OQ and also I have OQ equals to OR, let's say, then I can say what? OP is equal to OR. What is it? OQ equals to OR, correct, right? OQ equals to OR, then OP equals to OR. What is this? This is what? PRQ. What is this? This is QR. R. What is this? P related with R. Okay. This is the relation, the name of the relation, PRR. Okay. So reflexive, the transitive is also true. Transitive is also true. Okay. So yes, equivalence is there. It is an equivalence relation. Equivalence relation has her. Okay. आगे बढ़ते हैं. Question number 6. Now the functions part. Functions part, prove that the greatest integer function f, okay, what is it defined from? Domain and codomain are both what? Real numbers given by GIF. What is GIF? Greatest integer function, okay, is 1 1, neither 1 1 nor on 2. Arey, this is so simple. Check this. This is your function. Okay, for 1 1, if you have studied the graphical approach, what happens? If I draw a line parallel to x-axis, okay, for example like this, I draw a line over here, overlapping here, parallel to x-axis. It should have only one intersection, but on this line how many intersections are there? 1, 2, 3, 4, infinite intersections. Okay, so it has more than one intersections, right? It has more than one intersection, so basically it is many one, or what I can write directly here, not 1 1, not 1 1. Okay, what about onto? Onto means whatever is the codomain. Onto means what? Please understand this. Onto function means 1 1 function. What it means? If I have to recall this concept, please understand this. If I have two sets x and y, two set x and y, then each element, let's say this is my first element, second element, third element. Over here also if I have first element, second element, third element, okay, then each and every element in set A has to relate with only one element. Correct? This is my 1 1 function, this is my 1 1 function. That's the definition of 1 1. What about onto? Onto means that I cannot have a situation where I have an extra star left here. Means in this is my what? This is my codomain, right? This is my codomain. This is my codomain. So if I write my codomain, it will be given by how many stars? 4 stars. And if I write my range, range will be what? Please check here. 3 stars. Sir, what does this star means? Range means only images. So across these elements in X, please understand this. In this X set, what are the elements? These squares, 1, 2, 3 squares, okay. So for the first square, what is the image? Image is coming as the star, means what? Not the actual mirror image, okay. I'm saying this number relates with, this is not a square, this is a number here. It may be 1, 2, 3, A, B, C, whatever it is, and this will be something else also. So if this number relates with this star, this number relates with this star, then these are called what? These stars are called images, right? Images of the elements in what? Domain. So these images, if you take together, these 3 stars you take together, it will become what? The range. Is the range and codomain equal? Not equal, okay. So whenever range, what is the onto function? Whenever my range, not readable, sir. Whenever my range is becoming equal to what, bacha? My codomain. My codomain. Whenever this happens, then I can say function fx is what? Onto. Understand this. Then the other name of the function will be also called as surjective. Also called as surjective. This is called as injective. This 1 1 means injective. 1 1 means injective. I said no. Wherever revision is required, I'll do from the question only. So 1 1 means injective. Onto means surjective. Okay. If I combine together 1 1 and onto, it becomes bijective. If I have 1 1 onto together, we'll see in the next question. It will become what? Bijective. So now, this is just a concept part. Look at the problem now. Look at the problem particularly. I proved it to be not 1 1. 1 1 I proved it to be not true. Why? Because for one line, this is my one value of y, right? This is my one value. Let's say y equal to what? 1. For y equal to 1, how many x's are there? Please check. I can write x as 1.1, 1.2, 1.3 till the value 2, right? 1.1, 1.2, 1.3 and so many values, 1.111, 1.122. Why I'm saying this, sir? Because all this value, bacha, please check on the x-axis. For all this value, what is y? Y is only 1, right? For x equals to 1.1, what is y? 1. For y equal to 1.2, what is the y? Value of y? 1. So for all these infinite number of x's, I have only one y. Whereas the 1 1 function states that for one x, there should be only one y. So obviously not 1 1. Not 1 1. Okay? Not 1 1. What about onto? What is my codomain? Tell me here. Codomain is all real numbers. All real numbers. Whereas in this case, only, if you check here, only integers. So 1, 0, minus 1, minus 2, 2 and keep going on. I will not have any number. Is there a number between 1 and 2 there? Please check. If I write this number, is it there? No, sir, it's not there. So only integer is my range. Please check. Range is what? Range is only integer, not 2. Only integer, bacha. Range is only integer. I'm taking time here because I'm explaining you something. So range is only integer. For that reason, and the codomain is all real. So that reason, not onto. So the given function fx equals to greatest integer of x is not 1 1 or onto. Not 1 1, not onto. Okay, neither 1 1, not onto. Okay, done. This is the solution part. This is the conceptual part. I hope this is simple. 1 1 means uniquely related with the domain and codomain. Onto means none of the element in the codomain should feel left out. See, this star is feeling left out, no? It should not be the case. If I erase this part, it means what? Then it will be simply onto. If I erase the last star, it will become onto. But I've taken here, codomain is 4 stars, range is 3 stars, so not onto. Okay? Excuse me. Now this problem. This is simple, right? This problem. आगे बढ़ते हैं. Question number 7. In each of the following, Cases state whether the function is 1 1 onto or bijective. Okay, so is it just 1 1? Is it just onto, or is it the combination of 1 1 onto? I said na, when it is combination of 1 1 onto means bijective. So we have to check for that. Justify your answer. Justify your answer. कर लेते हैं. So I can do from this graphical approach or the mathematical approach. So let me show you the first one from both of them. First one I'll show you from both of them, and second one I'll show you from the graphical approach. So if I show you the, do you have enough space here? Yeah, I have. चलिए first one कर लेते हैं, पहली वाली. First one I'll show the graphical approach on this side. 3 minus 4x. What is that, बच्चा? Draw the graph. At x equals to 0, what is y value? X equal to 0. What is the function here? Please check the function. Y equal to 3 minus 4x. Yes or no? X is 0. What is y? 3. X 0. What is 3? Somewhere here. And what about y is 0? Y is 0, then x will be, check here, plus 4x equals to 3. So x will be 3 by 4. So less than 1. Somewhere here, right? Somewhere. This is my graph, right? Correct? Yes. Now please check. Is the graph of a straight line defined on which number? This is very important. Okay, this is very important because next I'll define it on. I'll define a straight line on what? On natural number. Then it will not be 1 1 on 2. See, defined where? All real numbers. Defined where? Defined where, sir? All real to real. Domain is also real. Codomain is also real. For that situation, you can see here, I can keep cutting at any point. I'll get only one. I'll get unique answers for y. So for one y, I have only one x. For one y, I have only one x. Means uniquely related. It means 1 1. It means, what is this function? This graph is y equal to 3 minus 4x. So 1 1 is there. 1 1 is there. What about onto? What about onto? See, what is the range? Range is all real numbers again. See, I can go to as long as negative y, and from positive y means range is also all real. Range is all real numbers. So it will be onto also. Because why? Codomain was also real, no? This is domain is R, codomain is again R. So again real to real. So will become what? Onto. So this is 1 1 onto means, but what is it? Bijective. What is this? Bijective. This is a bijective function because it is 1 1 and onto. Both of them are true. Graphical method is complete. Let's do the second one. We can use algebraic method. I'm teaching you both of them so that it will be used at times. Sometimes what happens in a question, no? Graphical is easy. Sometimes algebraic method is easy. So I'm teaching you both the methods so that you can relate to both of them. And if asked in a question, you can use either of them as per your convenience or your choice. Chaliye. Second one. So what happens in the case of your 1 1 function for this thing is, what bacha? If x1 is equal to x2, two values in what? What is x1, x2? Value from the codomain, domain. If x1 equal to x2, then this should have what? Condition as fx1 has to be equal to fx2. Please understand this. If I take a condition where x1 and x2 are equal, then fx1 and fx2 has to be equal. Correct, right? x1 x2 equal means what? Same point. So obviously it will have same value, na? This is the images, right? fx1 and fx2 are images. Correct? If x1 x2 same means same point, then obviously the value has to be same only, right? Correct? This represents y value, no? So same has to, it has to be same. So understand this from here. आगे बढ़ते हैं. What if I have a condition where not equal to is there? Then this also be not equal to. If I take two numbers 1 and 2, and over here I take a and b, then if is 1 equal to 2? No, sir. Then if 1 is mapping with a, then 2 will map with b. Is a and b equal? No, sir. Again, so 1 not equal to 2, then a and b also not equal. Is 1 equal to 2? 1 not equal to 2, then a is not equal to b. Correct? Correct, right? When 1 is not equal to 2, then a is not equal to b. That's also there now. A not equal to b. Then obviously if the condition is equal to here for the domain part x1 x2, then their function, related function y value will be equal. If it is not equal, then it will be again not equal. Okay, chaliye. This is the rule we use to solve the questions using algebraic method. Let's see. Now in this condition 3 minus 4x, so I'll take it as 3 minus 4x1 equal to 3 minus 4x2. So what I've taken here is, I've taken fx1 is equal to fx2. How, sir? Check here. This is the function, right? I've replaced the function by x1. 1 second. I have replaced the function by x1. Okay. So if you see here fx1 is equal to fx2, then what will happen? 3 and 3 will cancel each other. I'll get it as minus 4x1 equal to minus 4x2. Check here, again cancel this one. I get what? x1 equals to x2. Isn't that the first condition? If function value is equal means x1 x2 is coming equal. So yes, true. So this is what? What is this? This means 1 1. This is what? 1 1, no? This is for 1 1 bacha. What about onto? We'll see from the domain and codomain. So codomain and range. So please check here. If I write the function again like this, y equals to 3 minus x, 3 minus 4x, right? 3 minus 4x, yes. And what is the number defined for? Real numbers. Okay. Means if I take y to be real, then x should also come as real number. Why, sir? Y represents what? My range. Okay. So if I'm taking any y, then x should also come real. Why, sir? Please check here. Real to real. Okay. If I do that, what I'm going to get? For y belonging to real numbers, what will this be? Y minus 3 equals to minus 4x. So y minus 3 upon minus 4 will be equal to what? X. So if y is a real number, then this thing will also be a real number. Correct, right? If you subtract with a real number with a difference of real number divided by real number will be a real number. So x will also be a real number. Yes or no? So both of them are true. It means it is simply onto function. Onto. Now look at here. Second question. Again defined on real and real. Function is 1 plus x square. Function is 1 plus x square. First one is clear, right? 1 1 I have proved here and onto I have proven here. Okay. So it is bijective. Okay. Question number 2. Part 2. Part 2 is what? 1 plus x square. Y equals to 1 plus x square. Okay. So what we can see here? Yeah. So what is this going to look like? It's a quadratic function, right? If you draw the graph, it will be what? Either this kind or this kind. If you take this, okay. If you take this, what will happen? Please check. It will have 2 point of intersection, no? So how it is quadratic? Power is 2, right? Quadratic means parabola, right? So it means it will have 2 points. Acha, one more thing to see. If you don't want the graphical part, so it is not 1 1 from there. So first let's see here. First we conclude from here. Not 1 1 from here. Okay. If you don't want the graphical part, you can use it like this. Put function value at minus 1. How much is that will be? 2, right? 1 plus minus 1 square is 2. If you want to use 1, how much is that? 1 plus 1 square is 2. Again, algebraic method I'm saying. If you want to use the graphical method, you can see from here 2 intersection, so not 1 1. If you want to use algebraic method, f of minus 1 is 2, f of 1 is also 2. So again what? I got what? F of minus 1 is equal to f of 1, but what? Minus 1 is not equal to 1. What did I say? I said if x1 and x2 are equal, then this has to be equal. If it is not equal, then this has to be not equal. But I am getting equal but not equal. I am getting this combination. Equal here but not equal here. Please check. Yeah. I am getting equal here but not equal here. So again not 1 1. What about onto? Check for onto. Check for onto. So what is my codomain? My codomain is what? All real numbers. What is my range here? Please check the range. What is the range here? Starts from 1, goes to infinity. Can it go less than 1? If x is 0, I can go maximum till 1. The minimum value possible over here in this function is 1 only. I can take x as 0. For any other value, it will be more than 1, right? Because x square is a positive number. So if you add any positive number to 1, it will be more than 1. So what is my range? Range is 1 to infinity, right? 1 to infinity. Codomain and range are equal or not? They are not equal. They are not equal to each other. It means what? Not onto. It means not onto. Not onto. Okay. So we got for the second problem, not 1 1, not onto. Let's move on to the next question. Okay. So question number 8. Function defined from n to n. Defined by fn like this. Function is defined in n plus 1 by 2, n by 2. F is n is odd, it is n plus 1 by 2. If it is even, n by 2. Check for what? Bijective or not. Bijective means we have to check for 1 1 onto. Check for 1 1 on 2. Please check here. Please check here. How can I check 1 1? Same condition, I can use algebraic method. Let's check algebraic method. So if I take for function at 3, how much is that going to be? I have to use the odd number. So what will be 3 plus 1 by 2? How much is that? 4 by 2. How much is that? 2. Correct, right? F of 3 is coming as 2. Okay. What about f of 4? So 4 by 2. How much is that? 2. Okay. So what is this we are getting? F of 3 is equal to f of 4. But is 3 equal to 4? Function is equal. Function value at two different numbers are equal. So not 1 1. Not 1 1. So if it was an optional question, so I can say no bijective. It's not a bijective question, because if 1 1 is not there, it means it's not bijection, right? Both has to be true. 1 1 and onto. For onto we can check. For onto, it's what defined for natural number. Check here, please. If I take y as natural number, what will happen? Y equal to n plus 1 by 2. Please check here. What am I going to get? 2y minus 1 equal to n. Please see this. 2y minus n. I am bringing this 2 here and then bringing this 3 here. Bringing n, this minus 1 here. Not 3, forgive me. I meant to say 1. So I am bringing this 1. I get n as 2y minus 1. Think about it. Y is natural number. 2 times 1 natural number is natural number. Subtracted by 1, again natural number. So I get n as natural number. Natural number. So yes, second condition, this n by 2. If I take first condition, second condition, y equal to n by 2. Okay. Then what is this given? I have taken y as natural number. Okay. Then I'll get what? N equals to 2y. N equals to 2y. What will happen? N will be a natural number again. It means both the conditions is valid. So what is happening? Onto is there. It's a onto function. Okay. So not 1 1 but onto. Not 1 1 but onto. Onto is yes. It is a onto function. So आगे बढ़े. Simple problem. Very simple. आगे बढ़ते हैं. Question number 9. So that the function f n to n given by fx of 2x is not 1 1. This is a good question. See, usually what happens is you will say, sir, actually this is a straight line, no? Y equal to 2x. You have said always a straight line is 1 1 function. Okay, on to bhi hoga. In that reason, if you draw this line, what will happen? 1 1 on to, sir. 1 1 and on to. Okay, so bijection is true. Bijective function is true. Correct, sir? True. So answer should be bijective, but it is wrong. Not bijective. I'll tell you why. Because look at the domain. N to n. We are not talking about only what? Only real numbers. If I talk about only real numbers, this is true for real numbers, bacha. This is true for real numbers. Real numbers, yes, 1 1 on 2. What about natural number? Check here. So is it 1 1 function? Yes, it is 1 1 function. Correct. I can have one intersection, no? So if I take 2x1 equals to 2x2, what will happen? 2 and 2 will get cancelled. So I'll get x1 equals to x2. So what does this mean? This means f of x1 equal to f of x2, and this is giving me what? X1 equals to x2. It means what? 1 1 is a yes. 1 1 is a yes. What about onto? Check here. Function is y equal to 2x. If I take y to be y as natural number, okay, natural number I'm taking. What will my x value going to be? Y by 2. Y by 2. Yes, please check y by 2. Natural number by 2. Only if it is even, it will become natural number. If I take natural number y as, let's say 3, is 3 by 2 a natural number? No, sir. It means not always, not x is not always natural number. Okay, not always natural number. Means what? I got this as a condition where I'm getting x as not natural. So not possible. Y natural has to x be natural होना पड़ेगा. Please check here. Y natural means x has to be natural again. So it means what? Not onto. Not onto, sir. Not onto, sir. So it is 1 1 but not onto. It means it is not a bijection. It is simply 1 1 but not onto. So we prove that is 1 1 but not onto. Question is complete. Let's move on. Let's move on, sir. Good question, because if you take the graph, no, it says simply it is what? 1 1 onto. But there is a condition given for only if it was R to R, then I can take it as 1 1 onto. Simple bijection. Moving on. Function is defined like this. Oh, this is composite function. Gof is there. Okay. So we'll not read all the question. We'll read from this side. So we have to define gof from here. You see. We have to define gof. Gof where? where f is this, correct, right? So we'll start from the f. So gof of, let's do the first one. Gof of what? 2, let's do. Please check. G of f of 2. So f of 2 is how much? Please check. F of 2 is 3. F of 2 is 3. Please check here. F of 2 is 3. So this is 3. So it means G of 3, right? F of 2 is 3 means G of 3. G of 3 is what, bacha? Please check here. G of 3 is 7. This is equal to 7. So I can write my first ordered pair. First ordered pair as what? Starts from 2, goes till 7. So what for my gof? For my gof, my first ordered pair is 2, 7. I have to write for 3 also. Let me write it here. 3 also. What will come? We'll see. Then we have to write for what? 4 also. We have to write for what? 5 also. Do we write for other number? No, sir, because we are operating gof, right? So only for the domain of f we can define, right? What is the domain of f? 2, 3, 4, 5. So 2, 3, 4, 5 I've taken. I hope you understand this. I'm defining gof, but only for the domain of f, right? Domain of f is what? 2, 3, 4, 5. So I'm writing for 2, 3, 4, 5. For 2 I got it as 7. Let's do for 3 now. So gof of 3. When function is 3, what will this be? Please check f of 3 value. F of 3 is 4. Please check here. F of 3 is 4. So I'm writing f of 3 as 4. What is g of 4? G of 4 is again 7, bacha. So this will come as 7 again. I'll rewrite this ordered pair as 3, 7. Okay? Okay. Now I'm gonna do what? I'm gonna do gof for what? 2, 3 I've done. I have to do for 4 now. Please check here. I have to do for 4 now. If I'm doing for 4, it'll become what? G of what? F of 4 is how much? F of 4 is what? Please here. F of 4 and F of 5 is 5. Please check here. F of 4 and F of 5 is 5. So G of 5. What is G of 5? G of 5 is nothing but 11. Simply 11. I'll write it here as 11. So G of 4 is 11. Let me write it over here. The last step. G of what? Last number is 5. Gof of 5 means G of, what is F of 5? F of 5 is again 5. Please check here. F of 5 means, so G5 simply, what is G of 5? Same as 11. So answer is 11. So yes, in the question they have given some extra information. I don't have to go and break my head over this. I'll see what is the requirement and then I'll use the question to modify the question for ourselves. I did not need G9. I did not need other values, okay? I did not need this 3, all in the 3 I did not need, okay? So only for the conditions where I have the requirement. Okay, 3 I needed, right? 3 I needed. G of 3 is 7. I needed this 3. So my answer is what? My gof answer is 2, 7, 3, 7, 4, 11, 5, 11. This is my answer, bacha. This is my answer. Okay, आगे बढ़े. Simple question. Very, very simple. Okay. चलिए आगे बढ़ जाते हैं. Okay. Quickly, we'll move on. 11. Consider if previous one is done. Yes. Consider if f n y. Okay. Okay. Very good problem. You can see mentioned so many times. Has been asked so many times. Okay. F n y 4x plus 3. The function is given as y equal to 4x plus 3. Where y belongs to y equal to 4x plus 3. This is my condition for y. See here. This is what is the domain? Domain is natural number. But what is the range? Range is a set y. Y is a set, okay? And how is the set y defined as? Please check here. Set y is defined as the element of y. Y represents element of y is 4x plus 3 for some x natural number. Think about it. If x is natural number, what happened to 4x? Again natural. Natural plus 3, again natural. Basically, so y will also come to be a natural number. Y has to be a natural number also. I'll read this again. So what is this y? Y is the codomain set. What is this? Codomain, sir. Codomain, right? Y is codomain. Now how is y, the set y defined? All the elements in y is equal to 4x plus 3. Where x is what? X is a natural number. X is a natural number. Please check here. What x is natural number? 4 times of natural number is natural number. Plus 3 will be again a natural number. So y is also a natural number. So if you want, I can write it as natural number also. Okay. So not all natural number, but it is a natural number. Y is also a natural number only. None other possibilities are going to be there. Okay. चलिए आगे बढ़ते हैं. So we have to check. We have to find it is okay whether it is invertible or not. When I can say function is invertible when it is bijective. Okay. So I'll check for bijection first. and then find the inverse. So check for bijection. 4x plus 3, 4x plus 3. Please check here for bijection. I'm checking 1 1 now. I'm checking 1 1 bacha. It'll be what? Please check. 4x1 plus 3 equals to 4x2 plus 3. How much is that? 3 3 goes out. 4x1 equals to 4x2. 4 4 goes out. x1 equals to x2. It means 1 1 is there. How, sir? fx1 equals to fx2, so x1 equals to x2, so 1 1 is there. What about onto? Check for onto, please. Check for onto. Okay. Check here. Y equals to 4x plus 3 is there, right? Y equals to 4x plus 3 is there, right? Bring it over here. So, if I take y to be natural number, if I take x to be natural number, again y will also come as natural number, no? Please check here. If I take x as natural number, 4 times of natural number plus 3, again this will be natural number, okay? And this is the condition, natural number only. So, it is going to be onto also. So, it will be a bijection. It will be a bijective function. So, what? I can write it as invertible. It will be an invertible function, correct? Invertible means what? I can write the inverse. So, write the inverse here. Y equal to 4x plus 3 is the function. Put it here. Y minus 3 upon 4 I can write equals to x and change the subject. This is my function for x, right? Y minus 3 equal to 4 equals to x. Now, change the subject. So, I got y minus 3 upon 4 equals to x as the function for x. But I have to write for inverse function, right? For in x only. So, I write it as y equals to x minus 3 by 4. This is the inverse of function f defined from n to y. So, this will be what? What will this going to be? Simply a function g defined as y to n. Why, sir? Inverse will be interchange of what? Domain and codomain. So, n to y becomes y to n. Y to n. This is my inverse function. How did I check inverse? Whether it's possible to inverse or not? 1 1 and onto condition has been satisfied. So, bijection is there, invertible. Hence, I can check this to be inverse in this way. I can write y minus 3 by 4, change x and y, interchange x and y value, get y equals to x minus 3. This is my function defined like this, y to n, y to n. Okay, चलिए आगे बढ़ जाते हैं. Question number 12. R1 and R2 are equivalence relation in set A so that R1 and R2. Okay, they're saying this is equivalence. Please understand this. They are saying, I'll explain the question. This is equivalence. R1 is equivalence. They're saying R2 is also equivalence. They're asking us to prove that this is equivalent. Prove that intersection of R1 and R2 has to be equivalent. Let's check the first. So, I'll write first for R1. Okay. R2. Okay. I can write the space, according to the requirement. Please check here. So, I will write here, this much is enough for R1, this is enough for R2, and this is what? R1 intersection with R2. Okay. Now, check here. First of all, this is given equivalence. Equivalence is given. I have to prove your equivalent. Okay. So, first what I am doing for? I am doing for reflexive. आगे बढ़ते हैं. Reflexive, for it to be here, what's the condition? Please understand. A comma A has to be here. Means R1 should have A comma A. Yes or no? Yes. R2 should also have. Is it reflexive, right? Then R2 should also have A comma A. For it to be, since it is given equivalence, means R1 A comma A is part of this. A comma A is part of this. So both of these are this. R1 has A comma A. R2 relation also has A comma A. Then obviously R1 comma R1 intersection of R2. If you take intersection of this and this, intersection of this and this will be what? A comma A, no? So of course this also will have A comma A. Understand this. This had A comma A. This had A comma A. I am taking intersection of these two relations. So this will have A comma A. So simply what? Yes. S for what? Reflexive. Okay. It will become reflexive. Now let's move on to symmetric. Let's move on to symmetric. Symmetric means for R1 to be symmetric, AB and BA has to be there. Yes, AB and BA has to be there. Okay. Same way for R2 to be symmetric, AB and BA will be present here. Means for any number AB, BA will be there, no? In the relation R2 also. So R1 has AB BA. R2 has ABBA, so their intersection will not have A and BA. Think about it. R1 has ABBA, R2 has ABBA. Then intersection of R1 and R2 will also have AB and BA. Intersection will also have AB and BA. It means symmetric also. Yes. Think. ABBA is present here. Here also is present. Intersection will also have present. Okay. Moving on to the last one. What is that? Transitive. What should be there for it to be transitive? AB should be there, BC should be there, and AC should be there. Why I am taking like this? It's given equivalence. For it to be equivalence means it has to be reflexive, symmetric, and transitive. So AB has to be there, BC has to be there, and AC has to be there. For this to be again what? AB should be there, BC should be there, and AC should be there. Correct or not? AB, BC, AC should be there. What about this? Intersection of this and this. If I take intersection of these values from both the relations, I will get automatically over here also. AB will be here, BC will be here, and of course AC will also be here. Then transitive also. Yes. So I proved it. For the relation R1 and R2, the intersection of R1 and R2, it has reflexive, symmetric, and transitive. It means what? Equivalence condition is satisfied. So R1 intersection with R2 will also be equivalent relation. I proved it here. Please check. Please cross check. Okay, bacha? Okay. Now this question, 13th one. If the set A contains 6 elements, set B contains again 6 elements. If I write this as M equals to 6 and N equals to 6, M equals to 6 and N equals to 6. Okay, chaliye. M is 6 and is 6. They are asking us then the number of 1, 1 and onto mapping. What it means? Bijections only. Basically, they are asking us find the number of bijections. What is the formula? N factorial. Understand, this is only true for M equal to N. Because for M not equal to N, it will not be bijection. It will not be bijection. So only for M equal to N, I will get the bijection as N factorial. What is N here? N is 6. So 6 factorial means what? It means 6 times of 5 times of 4 times of 3 times of 2. Correct? 6 has a 30. 30 is here now. 30 times 4 is going to be 120. 120 times 3 will be what? 360. Times of 2 will be what? 720. What is my answer? A. Okay? A is my answer. Moving on. Next question. 14th. If A equals to 1, 2, 3 to N, then number of surjections from A to itself. Okay, A to itself. Think about it. I have starting from 1, 2 till N. And for this also 1, 2 till N. Surjection means what? Onto function. Onto function means what? Nothing should be left out here. Nothing should be left out here. This is my codomain, but it has to be equal to range. Means all the images should be having some value in the pre-image or in the domain. Okay, chaliye. For 1, I can have how many options? Please check. I can have n options. In fact, if I'm considering only one element, I can have how many options? N options. If I'm considering 2 elements, then how many options I'll have? 1 is reduced now. Think. For first element, I had n options. For second element, I have how many options? N minus 1 option. And same, I'll keep going till what? 1. For the last element, I'll have how many? If you consider all of them together, I'll have how many options? Only 1 option. Okay, so goes till n multiplied with n minus 1 multiplied with n minus 2 multiplied with 1. How much I get? This is simply n factorial. Answer is B. Simple problem. Very, very simple problem. Okay, आगे बढ़ते हैं. If function f is defined 1, 2, 3, 2, 1, 2, 3. 1, 2, 3, 2, 1, 2, 3. Choose the correct answer. Choose the correct answer. Please check here. 1, 2, 3 and 1, 2, 3. If f is 1, 1, if f is 1, 1, it will be 1 on 2, correct? Nothing is left. So first one is correct. Second one, if f is on 2, then f must be on 1, correct? Nothing, no extra element is there, means it will be 1, 1 also. If f is 1, 1, then it has to be 1, 2, correct here? Nothing extra is there. If everything is matched, then it will be 1, 2, it will be 1, 1. See, please check here. I am saying that if everyone is uniquely related, can I have other element present here, 3, 4, something like that? No. is defined, no, set, this is my domain and this is my codomain. The function is defined on this codomain and domain, okay. If you look at here, then if it is 1 1, automatically on 2, no. If I say uniquely related, then it is on 2 also. If I say on 2, it will be again 1 1 only. So even this is true, okay. This is not true. F is 1 1, then not on 2. We just prove 1 1 then on 2, okay. So option D, both A and B, both A and B. So option D is correct. What is it? 1 1 है तो on 2 भी होगा, on 2 है तो 1 1 भी होगा. If 1 1 on 2 is also true, on 2 then 1 1 is also true. Okay. All right. Let's move on. Okay, that's it. Let's move on to the next. So this completes your relation and functions. Next is what? Next is ITF. Next is, so we have completed how many questions? 15 questions on relation and functions. I've tried to cover up all the topics in relation and functions. Okay. So if you see, I've taken a little extra time to complete, some concepts also in between. So let's move on to the ITF, inverse trigonometric functions. चलिए आगे बढ़ते हैं. Okay, so inverse trigonometric functions, right? So again, let's look at what are the questions over here. So I think I will have another 10-15 questions, 10-12 questions to complete this unit as well, and we'll complete the today's session, which will be on relation and functions and inverse trigonometric function. Okay, so moving on, what is it, bacha? Let's see what is it. Write the domain and range. Okay, principal values you're talking about. Okay, so basically what they're asking is, okay, this is sec inverse x, forgive me, cos tan inverse f and cot inverse x. So first question is been asked again in April and May. Okay, 2022 and 2020 they have asked in May and April. Okay, this question, please check here. Write the domain and range. What type of domain and range? Principal value branches. So why principal value branches? Okay, if you remember this, cos, so any trigonometric function is not invertible everywhere. For example, if I take this graph of what? Graph of sin x. If you see this, right, this is my graph of sin x, right? It keeps going on both sides. So if I take any horizontal line, a line passing parallel to x-axis, it will cut at infinite number of points because it will extend to negative infinity and positive infinity on this side. Okay, so the graph will have how many intersections? 1 2 3 4 5 6. But for the inverse function to exist, what is the necessary condition? It must be 1 1 and on 2. Okay, so we have to perform some restriction, we have to do some cutting. Okay, let's see how the cutting will look like. So we'll ignore some parts here. Okay, what will ignore? So for the sin x graph, we will ignore this part. Please check here, or let's not, we'll ignore this part only. I'll write the ignoring part. So we will cut all of these. Okay, over here also we'll cut all of these. Now if you cut all of these, what will happen? What is left now? What is left? Only this part is left, bacha. Please check. Only this part is left, sir. Right or not? Right or not? Please check. Only this part is left. Okay, only this arch. So if I have to draw that, how will that look like, bacha? Like this. This is my graph of sin x. Graph of sin x. What's the domain now? The domain is minus pi by 2 to plus pi by 2. Okay, now if you draw a straight line at any point like this or like this, or like this, you'll get only one intersection for one line. Okay, now this function is 1 1 and on 2. Okay, so what we do now is, so after this restriction, so to make this inverse exist for the trigonometric function, okay, we have to perform some restriction over domain, right? So that restriction is what going to be called as my principal value branches. Okay, means I can repeat this, I can do this again, right? I can do this again. Next time will be what? So again I can take this part. Please check here. Correct? I can check this part again. Okay, so again I can take this part also. So I can keep taking these parts, but principal value will be this graph. Okay, so they are talking about for the principal value branches for all these inverse trigonometric function. Means this is trigonometric function, but I can take the inverse now because this has become invertible. It was not invertible earlier, bacha. Over here it is not invertible. Why, sir? Not 1 1 function, not 1 1 function, but in this case it is 1 1 now. So after applying the restriction over domain, the trigonometric function becomes invertible, and once done that branch can be inverted. How do you invert this? By applying what? The mirror image across this line, if you remember. Okay, y equal to x line. Once you do that, what are you going to get? Okay, this is my graph. Okay, looks complicated. If I erase some extra part, I'm going to erase this original line. Okay, let me erase this original line, and if I draw this graph, okay, what is my final graph for sin x? Sin inverse x, I mean, something like this, bacha. This is my graph of sin inverse x. Okay, y equal to sin inverse x. Few things to know: the domain will become range and range will become domain. It means this will be, y will be what? Ranging from, y will be ranging from what? Angle will be there. It will be angle. Means if sin operates, it will be a value. Okay, so I have to see here, check here. So if you see this value, now the truncated domain, if I look at this, what is this domain here? Pi by 2 to pi by 2, minus pi by 2 to pi by 2. Okay, what is the range here, bacha? Range is -1 to +1. Range is -1 to +1. So what will be my domain here? I said inverse means it will be, range becomes domain. So domain will be -1 to 1, both close. What about range? What about range, bacha? The range will become the domain. What is domain here? Minus pi by 2 to pi by 2. It will become what? This value. Okay. All right. I have told you. So I will be not, so our approach is what? Our approach is that we're gonna take questions. We're gonna take questions, and from questions only we will try to understand the concept. So this concept was principal value branches means what? Branches means since the sine and cos or any function is not always 1 on 2, so we use the restricted domain part. In that, if we draw the graph, now it is sine inverse graph exists. So for this value, what is my domain and range? What is my domain and range? Okay, so for this sine inverse x, you can see the domain and range is -1 to 1, minus pi by 2 to pi by 2 is my range. Okay, anyway, the value of y will be what? The angle. Remember this. Once you take sine inverse or any inverse trigonometric function, the resulting always is an angle. Okay, so check for sine inverse is this value. For cos and all, you can check here. Please check here. Sine inverse is -1 to 1 domain, range is minus pi by 2 to pi by 2, both closed. For cos, what is for cos, bacha? Again -1 to 1, but range is 0 to pi. For tan it is what, bacha? All real, minus pi by 2 to pi by 2, open. Okay, what about a sec? Sec is all real, but -1 and 1 is not part of the answer. It means I can write this as -1 union 1 to infinity. Means -1 and 1 are not part of the answer. Okay, anything between that. Okay, chaliye. For what about cosec? Same domain, ranges again not including 0. Here 0 is not there, pi by 2 is not there. Okay, why? Because sine 0 is 0, so inverse will be infinity, so not possible. Same way over here also, pi by 2, the cos is pi by 2 is what? 0, so in reciprocal will also be not existing in nature. That's why pi by 2 is not a part of the range. Here also 0 is not part of the range. This is degrees, or this is radians. This is the angle. Okay, angle. Okay, let's move on. So tan cot is what is cot? All real. Okay, all real is my domain, and 0 to pi is my range. 0 to pi is my range. Simple enough, very simple. So if you see this table, this answers your question here. 1, 2, 3, 4, 5, 6. All the answers can be taken from this table. That's why I explained you the graph of sine. What is the meaning of principal value branch? And then this is the list of domain and range for all 6 inverse trigonometric function. Let's move on. चलिए आगे बढ़ते हैं. Second, 17th problem or second problem for our this thing, our ITF. Okay, so that the following. Okay, so we have to use for these different 3 parts. We have to verify this LHS and RHS are equal. Okay, so let's see कैसे करेंगे. Let's see. 1 second. I selected black, right? That's why not visible. So let's do one thing. I'm doing the first part over here. First part over here. Assume this. Cosec inverse of x is theta. Assuming this, what happens, bacha? X becomes equals to cosec theta. Okay, this is my assumption. Okay, if I do that, what is the question given here? Please check. Given that sine inverse of 1 by x, isn't it? Sine inverse of 1 by x. Please look at here, 1 by x. So if I put the value of x from here, cosec theta, what I'm going to get, bacha? Please tell me. Sine inverse of 1 upon cosec theta. Yes or no? Yes, sir. This will become what, bacha? Sine inverse of sine theta. Yes or no? And how much is that? What I've taken here, this is my LHS, right? I'm trying to prove LHS equals to RHS. I've taken LHS over here I'm trying to prove it equal to RHS. Chaliye, this is how much? Simply theta. Yes. If this is theta, what is theta value? Cosec inverse x. What is this value? Cosec inverse of x. Cosec inverse of x. I hope this is clear. Easy, hai na? This is easy, right? So we got from LHS, we got it as RHS. So it means this is equal to what? RHS. So first one is proven. Yes. Let's move to the second one. So second one I will do. Third one you can do from your side. Second one I'll do. Third is to be done from your side. Okay. Please solve this. If you don't get this one, put this as doubt as well. Put this as doubt 17th. Okay. So this is my doubt. But it should not be. Let me do the second one. What is it saying? Again, we will take this as my assumption. Sec inverse of x will be what, bacha? Theta means what? Sec theta will be x. If I move this sec on this side, it will become sec theta, right? Then sec theta will become what? What is left here? If I move this sec on this side, it will become what? Sec theta. Okay, and this is just x left on this LHS side. Now use my LHS. What is my LHS here, bacha? Please check. LHS is cos inverse of 1 upon x. Basically, it means that I can write here cos inverse of, what is x, bacha? Sec theta. So 1 upon sec theta. 1 upon sec is what? Cos theta. I can rewrite this as cos inverse of cos theta. What is this? Simply theta. What is theta value? Sec inverse x. And how much is this? RHS. Right? RHS. So we have proven this step also. Third one, homework. Please solve this. Okay, just for practice. Okay? Just for practice. Same approach. Exact same approach you will do. You'll get the result. चलिए आगे बढ़ते हैं. 18th problem. Find the values of the following. So again, so for different value, tan inverse of 1, cos inverse of, it's a given expression. Okay, we'll operate this and we'll try to reach the solution. Okay, pehla wala, first one. Let's see the first one. Tan inverse of 1. We know tan inverse will operate on tan. That'll be easier, right? Tan inverse of 1. If you want to write 1, you can write directly as pi by 4 also. If you want to directly write this as pi by 4, no problem. Directly you can write it as pi by 4, sir. There is no negative sign here. Tan inverse of 1 is what? Pi by 4, no? So, sir, first one is pi by 4. Second one, cos inverse of minus 1 by 2. Okay? Cos inverse of minus 1 by 2. So, we know this as, this will be what, bacha? Cos inverse of minus x is pi minus cos inverse x. This is the formula. Please understand this. Cos inverse of minus x is pi minus cos inverse of x. Okay? So, pi minus cos inverse of what? 1 by 2. Yes or no? Yes. Okay. चलिए आगे बढ़ते हैं. Sin inverse of minus will be, if you remember this, sin inverse of minus x is formula number 1, formula number 2 is simply minus sin inverse of x. Okay. Simply minus sin inverse of x. Okay. So if you do that, what are you going to get here? Minus sin inverse of 1 by 2. Let's apply the angles now. This is simply pi by 4. This is simple pi minus cos inverse of 1 by 2. When is cos 1 by 2? Cos is 1 by 2 at pi by 3, right? Pi by 3, so it will become what? Minus pi by 3, correct? And when is sin 1 by 2? At pi by 6, correct? At 30 degree, it is 1 by 2. Pi by 3 means 60 degree, it is 1 by 2. Cos is 1 by 2 at 60. Sin is 1 by 2 at 30. Simple? Okay. Chaliye. Let's simplify this one. How much I'll get? Let's take the LCM. What is LCM? 4, 3, 6. So simply 12. What will this be? 4 3 is 12. So 3 pi. Okay. This will be 12 pi. Okay. Pi by 1, right? 3 minus will be what? Bacha? 3 4s are. So minus 4 pi. Please check here. 6 2s are. So minus 2 pi. How much this is coming as? Please check. 12 plus 3 is 15. 15 minus. Please check. 12 plus 3 is 15. 15 minus 6, right? Is what? 9 pi. By what, bacha? By 12. Simplify it. 3 pi by 4. This is my answer for the first part. Simple. Answer for the first part is 3 pi by 4. हो जाएगा. No problem. Second one should I do? Okay, चलिए कर लेते हैं. Okay. Second one, why don't you try? Same way, right? This is simple angle. 1 by 2. I've already done it here, right? Cos inverse of 1 by 2. I've written here value pi by 3. Tan inverse of 1 by 2 is again what is value? Pi by 6. Simple. Here it is positive, so I've taken here negative because the question was negative in this case. But here it is positive, so don't take the negative sign. and multiply 2 to this. Okay, so this you can practice from your side. So you can write it as practice, okay, homework part. Okay, you can do this, not a big problem. I'll do the third part. Tan inverse of root 3 minus sec inverse of minus 2. I'm doing third part, bacha. Not a problem, right? Tan inverse of root 3 minus sec inverse of minus 2. Am I right? Yes. Okay. So, for this I can directly write what? Pi by 3. At 60 degree, it is root 3. Tan is root 3. This will become what? Pi minus sec inverse of 2. Same rule as is cos inverse. Okay. Pi minus sec inverse of x. So if I do that, pi by 3 minus pi, and this becomes plus, yes or no? Minus pi and plus, this is minus pi, okay? And plus sec inverse of 2 is what, bacha? When is sec 2? When cos will be 1 by 2. When is cos 1 by 2? When it is pi by 3, है ना? If you are getting confused with the numbers, if you want, pause the video, write the table in front of you for all the angles, all the special angles, and keep comparing. Cos 60 is 1 by 2, so sec 60 is what? Sec 60 is what? 2, correct? What is 60 degree? Pi by 3 is 60 degree only, no? Okay. So what is this? Pi by 3 plus pi by 3 is 2 pi by 3 minus pi, right? How much is that? Minus pi by 3. Please check. This is my answer, bacha. So third part, what is the answer? Minus pi by 3, okay? This I have done, second one I have asked you to solve, okay? You'll get the answer. Please chalk. आगे बढ़ते हैं. Okay. Problem number 19, sin inverse of 2x 1 minus x square. We have to prove this LHS equals to RHS. Proof करना है LHS equals to RHS. So for the first one, let's see how we'll do the first one. Take the assumption x equals to, sin लेना पड़ेगा भाई, sin x, x equals to sin x. Take LHS now, बच्चा, ले लेंगे LHS. So what will this be? Sin inverse of 2 sin x. And what next? Times of 1 minus sin square x. Yes or no? Okay. One problem is there in all of this. I've taken x and x everywhere, okay? So this is my, I have to change the variable, right? Let's check theta. So theta, theta, theta. Any problem? No problem. Okay. Please check here. Will become sin inverse of 2 sin theta. And how much is this? 1 minus sin square theta, the whole root. So 1 minus sin square theta is how much? Cos square theta. Think. 1 minus sin square theta is cos square theta. Root of that will be simply cos theta. है कि नहीं? Cos theta. Okay. What is this going to become? Sin inverse of 2 sin theta cos theta. Sin 2 theta. है ना? This becomes cos, because 1 minus sin square is cos square. Root will act on it, will become cos. So cos with sin into 2 will become sin 2 theta. The formula sin 2 theta will be what? Simply 2 theta or not? Sin inverse of sin. What is it? 2 theta. What is the theta value? If x is sin theta, then theta is what, bacha? Theta is sin inverse of x or not? X is sin theta, I assumed. Then theta is sin inverse of x. लिख लीजिए यहाँ पे 2 times of sin inverse of x. Yes or no? Yes or no? Yes. 2 times of sin inverse of x. That's what we're gonna get, and that is what my क्या है भाई? RHS. First one is done, right? First one is done. Second one. Okay. What they have given? I think cos inverse of same thing they have given. Okay, no, sin inverse of same thing they have given. Okay, yeah, forgive me. Okay, just a second, sir, just a second. They have given what, bacha? Sin inverse of 2x 1 minus x square they have given. So I'm only talking about LHS for the part 2. I hope this is clear. Sin inverse of 2x times of 1 minus x square, the root. Only talking about LHS. Only talking about LHS. आगे करें. Again, this one will assume x equals to what? क्या assume करेंगे? X equals to, I can take cos theta in this case. Why cos, sir? You'll see the difference. Because this will become what? You'll see. So from here, what can I get from here? You'll get theta equals to cos inverse of x. That's why we have taken. Okay. If I operate cos inverse on both sides, it will become cos inverse of x. This will become cos inverse of cos. Simply theta. So theta equals to cos inverse of x is my result from here. Okay. Okay. Looks weird symbol. Let me simplify this. This is continuity. Okay. Now, put it here. Sine inverse of 2 cos theta in the root 1 minus what bacha? Cos square theta. My LHS only. Sine inverse of 2 cos theta. This is what? 1 minus cos square is sine square. Root of this will become sine theta simply. How much is that? Sine inverse of sine 2 theta or not? Yes. How much this will be? 2 theta or not? Sine inverse of sine is just theta. Okay. There are steps only. What is my theta value? 2 times of cos inverse x. 2 times of cos inverse x, which is nothing but my RHS. So both the conditions are proved. Ho jayega, no problem. Okay, simple. I hope you can see this. Yes. Aage badhe. Yes. Okay. Find the values of the following. Again, you have to simplify this. Sine inverse of sine is there, cos inverse of cos is there, tan inverse of tan is there. Sir, why don't we write this simply this as, sir, write this, no? 3 pi by 5, 13 pi by 5, 6 and 7 pi by 6. So few students will do this in your examination, okay? You'll go write this and you'll get 0 marks over here. Full masti you did, all got wrong. You have to check bacha the domain, right? Check the domain of sine, okay? Check the domain of sine. What is the domain here? Domain of sine is, if I check for the first one, what's the domain? Minus pi by 2 to pi by 2, close interval. Hai na? This is lying outside the domain. I have to make some changes over here. How will I make the changes? Please look at here. Okay. So I will write it as sine inverse of, I can write this as sine, maybe this pi minus 2 pi by 5. Yes, please check. I am writing 3 pi by 5 as pi minus 2 pi by 5. Simplify, 5 pi minus 2 pi will be how much? 3 pi by 5. So same angle. I have rewritten the same angle, no change. 3 pi by 5 as pi minus 2 pi by 5. Please have a look. If you take the RHS part, please check. 5 is the LCM. 5 pi minus 2 pi, how much is that? 3 pi by 5. Same thing. Okay. I have rewritten this angle 3 pi by 5 as in this form. Okay. Now the sine will operate on this. What will this become? Please check. Sine of pi minus theta is how much? Which quadrant? Second quadrant, right? Second, so will be positive only. So sine 2 pi by 5. Okay. Sine of pi minus theta is sine theta. So sine 2 pi by 5, how much is this value? 2 pi by 5. 2 pi by 5. This is your answer, bacha. Okay. Aage badhe. Okay. Yes. Any problem? This is simple, right? Check please. 2 pi by 5 is the angle, right? It is in domain. 180 times 2 will be what? 360. So almost 70 something. Correct. So this will be between what angle? Minus 92 plus 90. So earlier it was outside of the domain. 3 pi by 5 is out of the domain. So we had to make some change to get in the domain. And that was what? Writing this angle 3 pi by 5 as 5 minus 2 pi by 5. Same thing is written in this form. Once you use that, I am using the formula pi minus theta. Which quadrant is this? Please tell me. This is my second quadrant, na? Not confusing, please have a look. This is pi. This is my value what? Pi, right? 180 degrees pi. This is 0. If I move any angle over here, I'll reach which quadrant? Second quadrant, right? So pi minus theta will be second quadrant. Second quadrant sine is positive. So sine pi minus theta will become sine theta. So sine inverse of sine will become simply theta 2 pi by 5. Okay. Again, not relevant, and this is so incorrect. Do not write this part. Do not write this as your answer. This all is incorrect. Okay. You have to check your angle whether it is in domain or not. The angle 3 pi by 5 was in not the domain of sine. So first part is done. Let's move to the second part. Okay. आगे बढ़े. Cos inverse of cos 13 pi by 6. Second part. cos inverse of cos 13 pi by 6. Okay, okay. Anything incorrect I wrote? No. Again look at here. This is more than 2 pi. What is the domain of cos? 0 to pi. Domain of cos is 0 to pi, sir. But this angle is more than 2 pi. Then I have to make some change. How can I rewrite this as? Please check. I can write this as cos inverse of cos 2 pi plus pi by 6. Please check. Please check. If I multiply 6 with 2 pi, 12 pi plus pi, 13 pi by 6. Same angle written here, 13 pi by 6. So I've rewritten this angle in this form, 2 pi plus pi by 6. Any problem? No. Now we know that cos 2 pi plus theta, which quadrant? Please check here. 2 pi is this bacha. This is 0, this is 2 pi. If I go like this and add some angle to it, it will become what? First quadrant. First quadrant cos or all ratios are positive. I can simply rewrite this statement as what? Cos inverse of pi by 6, right? Because cos of 2 pi plus theta is cos theta only. Now what is the answer? Please tell me. Cos inverse of cos is simply theta. So pi by 6 is my answer. I am erasing few extra parts. It was not in the domain. I changed this thing to get the domain. My answer is what, sir? This is my answer. Simple, very simple. Third part. Third question. Please have a look. Tan inverse of tan 7 pi by 6. Tan inverse of tan 7 pi by 6. Again, please check. Out of the domain. What is the domain here? Minus pi by 2 to pi by 2 open interval. Sir, it is actually range, of tan inverse. I'm not talking about tan inverse. I'm talking about tan. Don't get confused. This is range. Yes, for tan inverse. But I'm talking about tan, bacha. For tan, the domain is minus pi by 2 to pi by 2. And this angle is more than pi. See, 7 pi by 6 means more than 6 pi, right? 6 pi by 6 will be what? Pi only. Pi is what? 180 degree. But the limitation is what? Only 90 degree. It cannot go beyond 90 degree. Okay? But angle is more than 180 degree. So obviously I have to make some change. How will I make this change? Please look. I can write this as tan inverse of tan pi plus pi by 6. ध्यान से देखिए. Please look carefully. 6 times of pi will be 6 pi plus pi is 7 pi. So yes, 7 pi by 6 I can write it as pi plus pi by 6. Pi plus pi by 6. What will this become? Please check which quadrant. Pi is over here. Pi plus pi by 6 means this quadrant. Some angle will come here. Third quadrant. Third quadrant, tan is positive. Third quadrant, tan is positive. So tan inverse of, this will be simply tan pi plus theta is tan theta. Tan what? Pi by 6. Simplify this, how much you will get? Pi by 6. Correct, sir? Tan inverse of tan will be simply angle pi by 6. Okay? Yes. This I will erase. This part I will erase. Not relevant. Domain you should know. Graphs, quadrant rule you should know to be able to apply in the problems. So I'm using only domain and the quadrant rule, okay, for the angles. Okay, so I hope the answer is clear. So if you want the answer, I can write it here. Finally, for this answer was 2 pi by 5, for this answer was pi by 6, and for this answer was pi by 6 again. Simple, simple. आगे बढ़ते हैं. Okay, question number 21. Solve the following equation. Means, what is the meaning of solve? Solve means find x, right? Solve means what? If the quadratic is given in terms of x, let's say, what we used to do? We used to find the x value, right? So we have to basically ask to find what? X. No problem. कर लेते हैं quickly. Okay. I have enough space. So do one thing. Tan inverse of 1 minus x upon 1 plus x equals to 1 by 2 tan inverse of x. Okay. Tan inverse of 1 minus x upon 1 plus x equals to 1 by 2 tan inverse of x. Okay. I think I went fast in last time. All right. Chaliye. If you see here, you can see the pattern being formed. 1 minus something, 1 plus something. There is a formula like this, right? Tan theta is what? Tan inverse of x by will be what? Tan inverse of x plus tan inverse of y, or tan inverse of x minus tan inverse of y. We'll see now. We'll see. Okay. We need that, no? We need that. Please check. Please check. So let's do one thing. I want tan only because tan inverse has to be operating on tan to get rid of this bracket. So let's take x equals to tan theta. कर लेते हैं. Let's see what will happen to this statement. It will become बच्चा tan inverse of 1 minus tan theta upon 1 plus tan theta. Right? I took x as tan theta. Okay, I'm taking only LHS. Okay, if you want I can take RHS also. Okay, ले लेते हैं RHS. 1 upon, what will this be? Tan inverse of, please check from here, if x is tan theta, then what is tan inverse of x? Theta, right? If x is tan theta, operate tan inverse on both sides, then what will happen? Tan inverse of x will be what? Theta, right? Simply theta. So I can write this as 1 by 2 theta. Tan inverse of x will be theta, so I'll write it as 1 by 2 theta. Okay. Now please look at the bracket part. Only bracket part you have to look. Next step. So I can write this as tan pi by 4 or not? Tell me. What I've done? I've written 1 as tan pi by 4 because tan pi by 4 is 1, tan 45 degree is 1. Over here I can write it as 1 plus tan pi by 4 times tan theta. Sir, how? Sir, how? Nothing is multiplied, bacha. Only tan is there. I can multiply tan with 1, no? Only x is written here. I can multiply 1 with x. So same way, I can multiply 1 with tan theta and 1 can be written as tan pi by 4. Yes? Okay. Sir, did not understand. I don't understand this part, sir. Okay. Check here. Tan theta, 1 plus tan theta is there. I can multiply, nothing is there means what? I can multiply 1 to whole thing, right? This one I'm writing it as tan pi by 4. No problem. Okay. Now check here. Tan of A minus tan of B upon 1 plus tan of AB. Please see here. Please have a look. I'm talking about this. Tan of A minus tan of B upon 1 plus tan of A times tan of B. This is nothing but tan of A plus B, sir. Tan of A plus B, not A plus B. A minus B. One mistake I did. A minus B. Tan of A minus B. Tan A minus tan B is there, right? Tan of A minus B. Okay. If I do that, what is going to become? Tan of pi by 4 minus tan theta. Please check. It will become tan inverse of. Okay. Tan inverse will remain same. And this will become what? Tan of pi by 4 minus theta. Tan A minus B. What is A here? A is pi by 4. And what is B here? Theta. So I can apply this and get it as tan of pi by 4 minus theta. Close this. Now what is left here? Theta by 2. How, sir? Please check. Theta by 2. Okay. Simplify this. Tan inverse of tan will be what, bacha? What will be this? Simply theta. Tan inverse of tan will be cancelled. The effect of tan will be cancelled. I will have only what? Pi by 4 minus theta equals to theta by 2. Yes or no? Bring theta on that side. I'll get pi by 4 equals to theta by 2 plus theta. Pi by 4 equals to 3 theta by 2 or not? Yes. Okay. What did I get? Pi by 4 times 2 by 3 equals to theta or not? How much is this? Please check. Theta equals to what? Pi by 2 into 3. Pi by 6. Pi by 6, sir. This is my angle. Is my answer? No, sir, not answer. Because what they're asking us, x value. What is my x value? Tan theta, sir. Tan theta. So tan of what, bacha? Pi by 6. How, sir? X is, theta is pi by 6. So tan of pi by 6 will be what, bacha? 1 by root 3. This is the value they were looking for. They ask us solve the equation. Means find x. X is how much? 1 by root 3. Please check. Okay. I hope this is visible. I hope this is visible. Moving on. Yes. Moving on. Okay. Now this problem. Question number 22. Simplify sine of tan inverse. Sir, how will I solve this, sir? Sine of tan inverse not possible. Yes, not possible. How will I work around this? What is this meaning of this, sir? Are they talking about domain, bacha? If you open this mod, it will become this only, no? Right? And that's the domain, right? I can have this domain restriction, no problem. Okay? That's the domain restriction, only that is given here. Okay? Let's do one thing. Take tan inverse of x as theta. Le lo. Tan inverse of x as theta. Let's take this. Okay? This is not 0, theta I'm taking. Theta I'm taking, okay? So what does this become? This over here becomes sine theta. Yes or no? Okay, I have to simplify here only sine theta. Multiply cos over here, and over here also you write cos. Cos over here and cos over here. I can cancel this. So I am just adding, multiplying denominator and numerator. What will this become? Please check. This will be tan theta times cos theta. Bring it here, bring it down. Tan theta y, what is going to become? If you go bring it down, it will become, I am bringing it to denominator cos theta. It will become what, bacha? Please tell me. Sec theta, right? What is the identity we know? Remember this identity? 1 plus tan square theta is sec square theta. So what is sec theta going to be? Sec theta is going to be 1 plus tan square theta in the root. Yes or no? 1 plus tan square is sec square theta. So sec theta is root of 1 plus tan square theta. Write it here. Tan theta upon 1 plus tan square theta, but in the root. But in the root. If tan inverse of x is theta means what? Tan inverse of x is theta means what? It means x is equals to what? Tan theta or not? Take this tan inverse over here. It will become what? Tan theta. Now replace tan theta by x. What is going to be? X upon root of 1 plus x square. My answer. Simplified. Answer is simplified. Simplify this. I got this as in terms of x, x upon 1 plus x square. Okay, 1 plus x square. आगे बढ़े. Let's move on. Okay. 23rd problem. 23rd problem. Sine of pi minus this thing. You'll see, looks complicated but very simple problem. Very, very simple. I don't even read the question. You'll see. Sine of pi by 3 minus sine inverse of minus 1 by 2. Yes or no? That's what they have given. I know the sine inverse of minus theta. Know this formula, please. Sine inverse of minus x is what? Minus sine inverse of x or not? Yes or no? Yes. I can apply this here. I'll get what? Sine of pi by 3. Okay. Minus. This minus will come out. Will become plus. Because this c minus comes out here. So plus sine inverse of simply what? 1 by 2 or not? Yes or no? Yes. Please check. Sine of pi by 3 plus sine inverse of 1 by 2 is how much? How much is it? When is sine 1 by 2? At 30 degree. 30 degree is pi by 6. Is pi by 6. Take LCM please. Sine of LCM is 6. This will be 2 pi. This will be 3 pi. Yes or no? Yes or no? How much is that? Sine of 3. Okay. 1 second. This is simply pi, bacha, not 3 pi. Simply pi. So 3 pi by 6. How much is that? Pi by 2. What is sine of pi by 2? Tell me. Sine 90 is how much? Sine 90 is 1. Sine 90 is 1. Answer is D. Answer is D. If you don't want to do that, you can see here also. Pi by 3 60 degree. Pi by 6 30, pi by 3 60 degree. Pi by 6 30 degree. 30 plus 60 90. Sine 90 is 1. You can write from here also. Okay. Sine 90 is 1. Okay. आगे बढ़े. Simplest question ever. Yes. 24th problem. Range of cos inverse of x other than. What is this, bacha? Remember this principal branch if you are considering. Okay. What is the principal branch of cos? Look at the graph of cos inverse. Cos inverse will have this graph if you remember. Okay. What are the values here? This is my 1. This is my minus 1. This is 0 and this is pi, right? 0 and pi, 0 and pi. It's not far, it's 0 and pi. This is, in Hindi we have something called as far, right? So this is simply 0 and pi. Pi is there, okay? Means this value is pi. Now this graph will continue after and before also. Yes or no? This is only principal branch, right? But the graph will continue above and below as well, okay? If you continue that part, what is before this? 0 to pi before will be what? This is 0. Before will be minus pi to 0. Correct, sir. Then after will be what? Pi to 2 pi. Correct, sir. Both of them are correct, means option D is correct. So option D is correct. Please check. This is the principal branch, but I can have this branch before and after also. Right or not? Like this I'll have. Okay. So that's what I'm trying to say. not B, not C. Both of them are possible. Both of them are possible. Before this will be what? Minus pi to 0. So C. And after this will be what? Pi to 2 pi. So both of them are possible. So option D. Option number D, sir. Okay. आगे बढ़े. Let's move on. Okay. 25th problem. Tan inverse of cos x upon 1 minus sin x. Okay. We are close to completing our session, bacha. First revision we are completing. I think only 2 problems are left, this and next one. And then what will be there? Will come with the next chapters, next series of chapters. So I hope you have made use of this session. I hope you have solved all the questions. If I'm going faster, do one thing, pause the video, solve your question, look at the table, because usually when I'm talking about angles, no, you might get confused. Sir, pi by 6 is what, pi by 3 is what? It happens. Even I was a student, it used to happen to me also, till date at times, okay? But what is the point? If you are not able to get that, keep the table with you for the special angles and use that in the questions, okay? Other place also, okay, for example, I'm writing simply, I'm saying this. If you're not getting it, know all the formulas, okay? One thing is very, very important, bacha. You should know, you have to know all the formulas, okay? That is non-negotiable, right? That is non-negotiable. So revise all the formulas. Apart from this, come here. I've taken variety of questions. A lot of questions can be expected. A lot of questions has been asked by CBSE in different examination, okay? You can see. So these are very, very good questions which covers all the concept in the chapter. But apart from that, if you're not able to understand this also, then go solve NCERT again, then watch the video, okay? Because you're preparing for your boards, right? NCERT based the questions will come. So if you're not able to understand even basics also, very, very basics. I've tried to take all type of question, simplest questions also I've taken. But even if you're struggling with that, go ahead, learn all the simple formulas from NCERT, then come and watch the video and we will complete your revision in the session, okay? Chaliye, okay. Thoda sa, we have little less time, bacha. We have to complete all the chapters before your midterm examination starts. For that reason, this is important that I cover everything on time, okay? आगे बढ़ते हैं. Tan inverse of cos x. So obviously, sir, we need tan something here. Otherwise, I cannot operate. Correct, right? Tan inverse will operate on tan only, not on cos. So how will I do it? How will I do it? Okay. So, sir, I can see one thing. Right now, there is no. So basically, we have to work around this bracket. What is the bracket? Write the bracket first. So cos x 1 minus sin x. Now we'll focus only on this bracket. Because if you see, these are all angles. Means tan inverse must have operated on this. So I need to simplify this bracket somehow in the form of tan. But that part will come later. That visibility will come later. Right now we have to simplify this. Okay. Now how will you get tan? Sin by cos should come. Sin by cos should come. Okay. Of some angles. One more thing is there. Very interesting. If you see the hint, they will give in the question x by 2, x by 2, x by 4, x by 4. It means the angle x will transform into x by 2. When that happens, if you have sin 2 theta, if you have cos 2 theta, that component is there, then only this can become x by 2 and what you call x by 4 like that. Okay. Chaliye. So if I am writing this cos x, remember this formula please. Cos 2 theta is equal to what? Cos square theta minus sin square theta or not? Yes, yes. So I can rewrite this statement as cos square. For 2 theta I wrote it as x. Here it is cos x. So I will write it as x by 2. Please see. For this angle I wrote half. So for this angle also I will write half. What is half? X by 2 minus sin square x by 2. Yes or no, bacha? Yes? Okay. I'll write 1 as it is. For this I'll get what? This will be sin x. What is the sin x formula? Sin 2 theta is nothing but 2 sin theta by, okay, 2 sin, not theta by 2. Bad habit, sorry. 2 sin theta cos theta. Now, for 2 theta, I wrote it as theta. So for x, I will write it as x by 2. So 2 sin x by 2 cos x by 2. Now please have a look here. So same thing will continue. I'll write it as cos x by 2 minus sin x by 2 a square minus b square and cos x by 2 plus sin x by 2. Please have a look. A square minus b square. So a minus b, a plus b. What about denominator, sir? What about denominator? Check here. I can write 1 as cos square x by 2 plus sin square x by 2. How, sir? Cos square theta plus sin square theta is 1. So cos square x by 2 plus sin square x by 2 is 1 minus 2 sin x by 2 cos x by 2. Yes or no? Yes or no, right? So I can write again next step. So what is this? This is the same thing, cos x upon 1 minus sin x. So cos x upon 1 minus sin x is continued to be simplified as cos of x by 2 minus sin of x by 2 times cos of x by 2, not entire cos, only for angle. So cos of x by 2 plus sin of x by 2. Yes or no? Yes. And divide by what, bacha? Divide by, please check here. Same thing I've written in the numerator. What? A square b square minus 2ab. A square b square minus 2ab. It becomes what? A minus b the whole square. There's a minus sign. So a minus b the whole square. I can write it as cos x by 2 minus sin x by 2 the whole square. Yes or no? Yes or no? Yes, sir. Please cancel this. One of this will be cancelled. What is left now? This will become what? Please check. It will become cos x by 2 plus sin x by 2. So cos x by 2 plus sin x by 2 upon cos x by 2 minus sin x by 2 or not? Yes. Divide everything by cos. Why, sir? I want tan. Remember this. Operating on tan, sir. I have to operate in tan. So my goal is to get tan here. So if I divide everything by cos x by 2 obviously, I'll get what? This will become 1. This will become 1. This will become tan x by 2 or not? Please check. Cos x by 2 by cos x by 2 will be 1. Sin x by 2 by cos x by 2 will be tan x by 2. Same I have to do for denominator also. Effect has to be repeated. So cos by cos will be 1. And this will be what? Tan x by 2. Yes or no? Cos x by 2 is 1. Sin x by 2 by cos x by 2 is tan x by 2. So this can be written as what, bacha? I can write again same thing I used in the previous question. Tan pi by 4 plus tan x by 2. Not visible. That is not n by 2. This is tan x by 2, okay, upon what? 1 minus, same thing I'll multiply here, pi by 4 and tan x by 2, okay, tan x by 2. What is this going to become? Please understand this. So I will have a transformed equation now. Please check what will this be? Cos x, this one I'm saying, cos x upon 1 minus sin x. This one is going to become equal to what? This value. This value, how much is that? Please check. Please check. Tan pi by 4. Okay. Okay, I can write directly also, right? I can write directly also. Please check here first. Tan A minus tan B upon 1 minus tan A tan B. So what will this be? Tan of A minus B. This is plus, right? So this is plus, this is minus. So tan of A plus B. Please check. This was plus. So this is plus. Tan A tan B 1 minus tan A tan B. I wrote it here somewhere. I wrote here, right? I wrote here somewhere in the previous question when I was solving. Yes. Tan A minus tan B, it was there. It was here minus sign. In this case, it is having what? Plus sign. This will become plus. This will be plus and this will be minus. If this is plus, then this will be plus and this will be minus. Okay. Please now, let's see. Okay. 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 So it will become tan A plus B. Tan A plus tan B upon 1 minus tan A tan B. Tan A plus tan of A plus B. Okay. So I can rewrite there as tan of pi by 4 plus x by 2. What is the question saying? Question says, bacha, tan inverse of this thing, right? This thing. I can rewrite this as this part. Operate the angle over it. Tan inverse of tan will be simply what? Simply pi by 4 plus x by 2. My final answer. My final answer. Okay, pi by 4 plus x by 2. Any option like this? First option only. Pi by 4 plus x by 2. Simple problem. Simple. Okay. But yeah, You have to think a little bit. Solvable, not that challenging, but it has certain aspect to it which will make your, you have to think. Your brain has to think, okay, to break the problem. How can you break the problem? Let me do it again for you. Tan inverse has to operate such that angle should come, correct? Now angle will only come if the tan has operated, tan inverse has operated. It means this has to become tan of something, this has to become tan of something. How can it become tan of something? I don't know, sir, right now. But I know that one thing is that x is becoming x by 2, means compound angle. The formulas can be used there, okay? What a formula I can use? For cos 2x, I use this formula. For sin 2x in the denominator, I use, not 2x, sin x, I use this formula in terms of x by 2. Simplified it using a square minus b square, and over here, a plus b the whole square. I got some cancellation, and then it was easy because I can just divide by tan and becomes the formula tan of a plus b. Once tan of a plus b is there, I replaced the whole thing by tan. Tan inverse operated, got the answer as pi by 4 plus x by 2. So know the flow. What is the requirement? Then the brain will automatically give you the answer. So have a look, please. Have a look. I hope this is visible. This is also visible, right? Okay. I think this is the last problem of the day. Okay. Quickly complete it, and then you can carry on with your work and carry on with your revision actually. Do not waste your time, bacha. Do not waste your time. So cos inverse is operating on this value. Okay. We know this is the formula, right? 4 cos cube theta minus 3 cos theta. What happens actually is, sometime what will happen, no? They will give you the domain, they'll give you the domain, the x value, and they'll ask you to prove this, okay? That type of question is also possible. Then what you're going to do, take x as cos theta. It'll become 4 cos q theta minus 3 cos theta. It'll become cos 3 theta simply. That's what it is written here. Cos inverse of cos 3 theta is what? Please check. Cos inverse of cos 3 theta is what? Simply 3 theta, no? So 3 theta, okay? 3 times of theta, okay? Because you assumed x to be cos theta, so cos inverse of x will be theta only. But that is a question that can be asked. You can actually expect this question. This can come in examination, but this is another category. This is rarely asked, but very smart question. Very, very smart question, okay? If it comes, it will be a very good problem. And 50% of students will not be able to solve this question. That's why I have taken this problem. This you will solve. You will find this solution everywhere. Cos inverse of cos theta. In the example also, you might solve this question, okay? Okay, this is available everywhere, but I am working about a domain. How to reach this domain, okay? Means for what domain this is true. The question is, for what domain this condition is valid, okay? Chaliye, dekhte hain. So far we know one thing, that cos inverse, if it is operating, please see here. So let's take one thing first. Let's take one assumption. Cos inverse of x, we will take it as theta only. We will take cos inverse of x equals to what? Theta, no problem, okay? So what this value, this whole value, please understand this, this whole value, cos inverse is operating on this. Forget about RHS right now. Just look at this. This cos inverse will have what range? What is the range? Correct? 0 to pi or not, both included. Correct? 0 to pi. And what is the value coming as? This value. What is this value? 3 theta. Understand this. I have taken cos inverse x as theta. So it simply becomes 3 theta. Please understand this. This resulting value of cos inverse will lie in which bandwidth. The resulting value of any angle coming out of cos inverse will lie in this range only, because this is the range, okay, of what? Cos inverse of x is what? 0 to pi, right? Included. That's what I've written here. 0 to pi. Why 3 theta, sir? Because the value is 3 theta. Because the value is 3 theta. Okay. Divide 3 on both sides. I'll get 0 here. I'll get theta here. I'll get what? Pi by 3 here. Okay. Pi by 3 here. Now one thing you'll see. Okay. Apply cos on all sides. Write it as cos 0, cos theta, and cos pi by 3, and cos pi by 3, and cos pi by 3. Please remember this. I applied cos on all the inequality, across the inequality. There are two inequalities here, so across both inequality. Cos 0, cos theta, cos pi by 3. What will happen? How, sir? I think few of you will know this answer. If you don't know, I will tell you. What's the case? Because cos is decreasing function, sir. It's a decreasing function. If you operate, inequality will change. Remember this. Cos is decreasing means if you multiply with a negative number, what will happen? What will happen? The inequality reverses, right? So multiplying cos will change the inequality. Change the inequality. So the less than becomes greater than, and the greater than becomes less than. Okay. So this is less than. So here less than becomes greater than. Less than becomes greater than. The now change order is changed. What is cos 0? Cos 0 is 1, sir. Okay. Cos 0 is 1. And what is this? Simply cos theta. And what is this? Please check. Cos pi by 3 is what? Cos 0 is 1. Cos pi by 3 is cos 60, which is simply 1 by 2. Which is simply 1 by 2. Now look at this part. Okay. I'm going to write in this order. So I'm right here 1 by 2 less than equal to cos theta less than equal to 1. Okay. Okay. If cos inverse is theta, then what is cos theta? X, right? Bring this cos inverse over here. I'll get x left over here and becomes cos theta. Or what other thing you can do is operate cos on the both sides. It will become cos of cos inverse will be simply x, and this will become cos of theta will be simply cos theta. So x will be what? Cos theta. This was the assumption, right? This is my assumption. Let cos inverse of x is theta. Then what is x? Cos theta. So what is my cos theta going to be? Isn't this the answer? Please check. 1 by 2 less than equal to x less than equal to 1. 1 by 2 less than equal to x less than equal to 1. Option number B. Thana, acha question. It's a good question, right? I hope you understood this. Very, very good question, bacha. Very, very good question. Okay. So what was given? For the given condition that they have, what domain will be active? What domain will be true? What is the domain is that? 1 by 2 to 1 close intervals. 1 by 2 to 1 close intervals. I hope the session was fruitful. I hope you understood everything. Okay. So this completes our revision part 1, where we have taken 2 chapters, relations and functions and ITF. I really hope you're gonna work a lot. Okay. No time to waste right now, and complete your revision. Solve each and every question that I have done. How many questions I've done? I have done almost 26 problems. Okay. So solve all these questions. Again and again until unless you get hold of the concept. Question so you can solve, okay, understand and solve. But if you get the hold of the concept, by the question it will be very, very helpful. Because in the exam you're going to do what? Solve the questions only. Again, one more thing. Since it is PU2 examination, if you are worried about what steps to write, stick to your NCERT steps, okay. Textbook steps is what you should write in examination. No other steps, okay. I've tried to write all the steps for all the questions, but if I've missed any step, don't worry. Write your NCERT steps. What are the steps given in the NCERT? Similar steps you write in your answer key in the examination. Okay. So this is revision part 1 for your PU2 examination for midterm. I hope you are all working hard. Okay. So complete this. I will again come back with your second video very soon for the part 2, which is going to be the part 2 of your revision of the next series, next set of chapters. Okay. Till that time, take care of yourself, work hard and keep positivity around you. Be positive all the time. Okay. Try to be positive. If not, you can't be positive, sir, hard line. I'll be positive. Try to be as much positive as you can. Be kind. Keep working hard. See you in the next session. Take care. Bye-bye.